Definition of a logarithm. For y greater than 0 and b greater than 0, and b not equal to 1, log base b of y is called a logarithm in base b of y, and is the power of b that gives y. In other words, I know that sounded really confusing, didn't it? In other words, my brain's gonna let me word this very well today or not. I kind of just like to say a logarithm is an exponent. Okay, so think of it this way. If you have an exponential, y equals b to the x power, then an exponential can be rewritten as a logarithm in this form. X equals log base b of y. So notice in our exponential, x is the exponent. In our logarithm, x, the exponent, is equal to the logarithm. So the logarithm literally represents the exponent in our exponential. Why do we need such a thing? Because it's an inverse. Notice how my x and y more or less switched places. So instead of x being the exponent, we now have a logarithm that's the exponent with the y in it. So it allows us to trade our x and y so that we can solve things with exponents that we wouldn't be able to solve otherwise. Okay, let's look at a few little practice items. Finding the values of logarithms. So remember, since a logarithm is an exponent, when we're evaluating a logarithm, what we want to do is ask ourselves, what is the exponent that would make the base of the logarithm equal the number? So 3 to what power is 81? That's what I'm going to ask myself here. 3 to what power is 81? Okay, so you can use a variable for that if you want to. 3 to what power is 81? So we have to think through that. 3 times 3 is 9, times 3 is 28, times 3 is 81. I think I had to multiply that 4 times. So 3 to the 4th power, that means the value of our logarithm is 4. The logarithm literally is the exponent. The exponent that makes this true is 4. 3 to the 4th power equals 81. So the value of the logarithm is 4. It is the exponent. Let's look at number 2 for the same type of idea. 5 to what power is going to give us 1 over 25? Well, we have a reciprocal happening in here, so we definitely need a negative. And then we have 5 squared, which is 25. So would it be 5 to the negative 2? That gives us 1 over 25, because that would give us a reciprocal, and it squares our number. So 5 to the negative 2 power equals 1 over 25, I believe. That means the value of our logarithm, the logarithm is an exponent, the exponent is negative 2. Last one, 4 to what power is 4? Well, that's easy, it's just 1. So the value of the logarithm is 1. Okay, So anytime you have the logarithm with the base and the value of the logarithm is exactly the same number, see how these are exactly the same? The value of that logarithm is 1 because the base to the power of 1 is the number in the logarithm. Okay. Sometimes we just need to switch between forms. So the first 3 examples here were evaluating logarithms, finding their value. But now we just want to change between logarithmic and exponential form. So we're not solving anything, we're just changing forms. So to change log base 6 and the square root of 6 equals 1/2 into an exponential instead, we would rewrite that as 6 to the 1/2 power equals the square root of 6. Is that a true statement? That's just another way of writing a square root. Okay, number 2 is written as an exponential. We want to write it as a logarithm instead. So instead of 10 to the -3 equals 1/1000, the base of our exponential becomes the base of our logarithm. Now technically base 10 we wouldn't actually write the 10, it would just be called our common logarithm and we wouldn't write it at all. But we'll talk more about that later. Okay, so log base 10, and then this number here is the input or the argument of our logarithm. And then that's going to equal our exponent, because remember a logarithm is an exponent. So the statement that, I don't know if you guys remember me having that around my classroom, a logarithm is an exponent. That statement just helps me, it's just a quick way of memorizing how to switch between forms. As long as I always remember the logarithm is the exponent, is equals, the logarithm always equals the exponent, then I can usually get my brain to remember how and what order to put things in. Okay, solve the following equations by first changing to exponential form. So for this problem 3, I'm going to change it to exponential form, so instead of log base 3 of x equals 4, our exponential form for that would be 3, I'm on an eraser, 3 to the 4th power equals x. All I've done is just like I did in example 5, I've switched from log form to exponential form. That makes this problem really easy to do because what's 3 to the 4th power? Well, let's see. 3 times 3 is 9, times 3 is 27, times 3 is 81, x equals 81. We solved our logarithmic equation simply by changing it to exponential form. Let's try the next one. So log base 2 of x minus 1 equals 3. Remember, the logarithm is the exponent. So the 3 is the exponent, so when I take the log base, that becomes my exponential base. The exponent is what that log is equal to, and then the other part, the argument of the logarithm, just goes over here on the other side. So now I just do this math. 2 to the 3rd power, so 2 times 2 is 4, times 2 is 8. 8 equals x minus 1. I just want to get x by itself, so I'm going to add 1 to both sides. And I solved my logarithm equation, x equals 9.